Okay, so hopefully I won't fumble anything and require to use the return key.
I mean the escape key?
The escape key, yep, sorry. So, say for example, just to give you a sense as to why parameters are important.
Can you make the font a little bit bigger?
Not in this one, I can't.
On this one?
So let's say instead of multiplying it by 12, I multiplied it by itself.
Like you're squaring it?
Yeah, I could do that, and then I could add another number, and then I could, do something else with it. So, for instance, let's say I want to take the value of itself and add it to itself with some multiplier. Okay, so now I have a function. It's going to do this whatever math calculation, right?
You can't represent function input first parameter with a parentheses and then a caret squared, or do you have to times it? Like, can you know in math you represent a parentheses like this with a caret and square? You can't do that here, or will that?
Some languages support that. I think JavaScript interprets the caret as some other operation. I forget at the moment, but it might be like the logical OR rather than exponent.
In an exponent function, yeah.
Yeah.
Remember when math, the exponent, yeah, the caret on the calculator.
Yeah. So I think in this particular case, it's going to treat it as a different operator. It's going to treat it as a Boolean operator rather than as a thing. But I'm not sure. I'd have to double check. I don't really use the character for that purpose very much. There are math functions that can do exponents, for example. I think it's math.exp, but let's not do that right at the moment. So rather than using this other variable, I'm simplifying the code a little bit because I want to cover another point. Okay, so what's that going to do?
So, should we start from the top or right at the var function, simplest one?
Yeah, I would say start there. Start at the simplest one. Well, it's not the simplest one. Let's change the name to something a little more reasonable, some odd calc perhaps.
Oh, it automatically replaces it when you do it?
My editor does stuff.
Oh, okay. That's nice. It saves time. Yeah, it's kind of like the replace all function on it.
It's very similar to that, yeah.
That's good. Yeah.
Okay.
So we'll start at the variable function sum odd calculation 1 is defined as the function, and now you're going to call it the first parameter. It goes down to the variable mlval1 was represented as, was it 12? Was the top?
I took it away.
Oh, okay.
I changed it.
Mlval. So the variable mlval1 is equal to, it's defined as a function of sum mod calculation, and you're calling 45. Oh no, 45 is the parameter.
Yep.
And then 45 is the parameter. Now it goes to function log. Function log of 1 is equal to ml value of 1. So you're calling the function of log 1 to the parameter 45?
Nope.
No. The function of log 1 ml value is the function of some odd calculation of 45. Oh, so that's nested inside of that now. Then you go up to the function input, the first parameter. You changed what it was representing. Before it was 12. Where did it go?
12's gone. There's no 12 anymore. I changed the code. You watched me do it, in fact.
Yeah.
I was editing while you were looking. So what happens?
So you're defining the first parameters as everything in the brackets. So everything, the definition of the function parameter is...
The function parameter is going to receive
everything inside of that.
Nope, it's going to receive the 45. See the parens here?
Mm-hmm.
Parens I have a 45 in the parens in my function call.
Mm-hmm.
It's a function call because it's essentially some variable, and then the parens indicate that it's a call, and then the thing inside the parens is the value of the parameter. So when I define the function, you see I have parens up here.
Mm-hmm.
It's just like that. So you see how function parentheses, so I'm going to insert
45
for
the first parameter
as the value of the first parameter.
Okay. Why isn't it written like that then? Why is it like not returned on the lower line?
I put it on the lower line because that's a way of formatting it. Because if I want to make a comment,
it's going to be everything below it.
It's going to be on the thing below it.
Oh, okay. So that's the bracket and the end bracket. Okay. So it's just the formatting. Got it.
Yep.
Oh, okay.
It's one of those things that I just routinely do. But like I said, it makes more sense if it looks like that.
Yeah, okay. So the variable function model calculator 1 is equal to the function, and you're calling the function with first parameter, which is 45. Yeah, so that's 45. So basically the variable FL example 2 is function put first parameter, which is 45, times 45. 45 times 45 is...
Don't figure it out. Just go with the narrative.
Yeah.
It's something.
It's, let's say 240. 240 plus 123. So now, that is what FL example 2 represents.
Mm-hmm.
And then FL example 2 is, now you're going to basically, FL example 2 is now being represented as, let's just say that was a 203, let's just say that's 380 now, so it's 380 plus 380 times 1.5. So that's 760 times 1.5.
Don't do the math in your head. The computer will do the math. It'll give you some value, okay?
Mm-hmm.
So whatever that value is going to be put in example 2. So example 2 just updated itself.
Yeah, it's going to return some number around like 1600.
Uh-huh.
If FL example 2. And then now we go back to example 2. So the variable ml_val1 is equal to, because now it's going back down.
Right.
The function of some odd calculation is 45. And the function of log1 is what that represents. So that is equal to 700 something. fn log1. And you go to variable some odd calculator 67. So now you use 67 as the first parameter.
Yep.
So you go back up to the first parameter, you square it plus 123, and then it comes down to the next line, and then you double it times 1.5, and you get that, which is going to represent ml_val2.
Uh-huh.
And it'll output whatever that is.
Right. So what do you expect to see on the screen when we run this?
Like a big number, right?
Just one?
No, we'll see two numbers. We'll see the one with the parameter 45 and a second number represented by the parameter 67.
Congratulations.
Yeah. On different lines, yeah. I wasn't sure if it was separated by comma.
Well, I put it so that it was on every one of those logs will print on its own line. And that's just something I wrote in. I wrote it in by adding, just in case you're curious, this BR.
The break, yeah.
This is the line break.
So line breaks, okay.
So
I was wondering how that happened.
I particularly added the line breaks.
Okay.
So if you look at the structure of the document, so if I pull up the inspector console again.
Yeah, because if you had taken that out, it would have just had them next to each other.
So here's your HTML body.
Yeah.
This is your script tag, so it's got all of that code in it.
Mm-hmm.
But let's close the tag off.
And then you have the break.
And then I have the breaks. So this is what it looks like. And you see how down here it's got the the comment at the bottom. Mm-hmm. But we're going to pretend we can't see the console anymore. So what if I were to change it to that?
It would be essentially it would be you get the same number, the second number would be the same. But the first number would be a huge number. Yeah.
So it switched to scientific notations. That's why I've got e plus 25.
Changed, yeah.
Right. So
yeah.
now.
Exponential to the 25th.
Yeah. Okay. What if I do something more reasonable, and then something a little less reasonable?
Oh, so it'd be a 400. Oh, so whatever the output of 453 is when you calculate everything, it's that when you throw it back in, you basically double it plus 123, double it times 1.5. Yeah.
So you can see I can route data around, right?
Yeah. Yeah. Makes sense.
Okay, so you're beginning to see why composing things in a function is helpful, because I wouldn't be able to do stuff like this unless I had already set up a sub-recipe with a parameterization. Now I can create more than one parameter.
No, this is a P2.
Yep.
It was P1, P2, okay.
Oops, hold on. There we go.
First parameter, comma, F1, second parameter. Yep. You change it, so you separate it with a comma, but it's on different lines. Cause
right, but this is separated with a comma here too, right?
Yeah.
Okay, so now we're using the second parameter as part of our calculation. Right? So you see how we've just extended the power of our calculations.
When you have two parameters, do they run in order? Like one has to go through and then the second one, or do you run
No,
them?
it's basically the same as the first parameters in this case. When it calls the first one, the 453 is going to be assigned to the first parameter because it's the first thing in the comma. And the second thing after the comma will be assigned to the second parameter.
It's like x1, x2. Okay, so when you go through, it'll be a 453 plus 453, times 453 plus 123. And the second one will be whatever the sum of that is. Double it times 1.5 times 35.
In this case, yes.
Yeah, because you're just inserting the 35 as the second parameter.
Now, incidentally, these infix operators, the plus sign is an infix operator, the multiply. The multiply has higher precedence. So it's as if I did that.
Right?
What's that?
Appendus. The order of operations.
The order of operations I just specified with the parentheses. So, on the other hand, this calculation is different than if I put the parentheses here.
Yeah. Because that, So you do the parentheses first, and then exponents, then multiplication.
Now you notice
division,
that this is the parentheses is specifying this as an infix operator.
Yeah.
Whereas if I put some token here, that would make it a call.
Yeah. So you would do it in the parentheses first, call it, and then times it.
Well, the parentheses have two functions. I use them as a grouping thing in math. I also use them as a signal if it's calling a function. And the way that the interpreter tells the difference is that I don't have some symbol to the left of the parentheses. If I did, it would treat it as a function call.
Got it. Write that down. You can represent grouping of parameters.
I'll leave them in there.
Represent order of operations too.
Yep. And how it tells the difference is based upon
if you have
if there's a token, if there's a symbol to the left of the left parentheses, it'll assume that the symbol on the left is a function call because it's followed immediately by a parentheses, by an opening parent.
Right, so you have a function call in front of it, it's order of operations. If you don't, it's a grouping of parameters.
That's right. So I'm going to save this as, well, let's run it first just so you can see it. Okay, so two numbers. Get a new file.
Save recording, this is part 3.
Okay, so I just transitioned to sample 3. By the way, the title on sample 2 is wrong. Let me fix that while I'm at it. Okay. Actually, I'm going to leave that in there for a minute. Okay, so we now have this new code. Can you tell me what that one's going to do? It does the thing you expect it's going to do, but you got to read it to see that.
So the variable is function of sum on calculation 1, and the function is defined as first parameter comma second, and the second parameter is defined as. So we're starting down here.
Well, it's doing the definition, then it's going to basically do
the definition of everything.
Yep.
And then you go down to so it reads the definition of everything.
So everything else is the same about this program. Like all the stuff down here hasn't changed.
But the definition of has changed. So it's the variable example 2 is equal to the function input of the first parameter times the first parameter plus 120. That's the same.
Yep.
Now this is a conditional statement. So that's if the second parameter is greater than 15.
Yep.
So then it'll be defined as the function of example 2 is equal to.
So it'll do the things in the curly braces.
Only if the second parameter is greater than 15.
That's right. And it won't do the stuff in the parentheses otherwise.
It's lower than, or equal or less than.
Yeah. And so this is actually a third usage of the parens as to demarcate the logic of the conditional.
Okay. Yeah, so the parentheses define the logic of the conditional.
Yeah. So you see it used parentheses as function definition, parentheses as function calling, parentheses as order of operation, and parentheses as part of a conditional. There's one other thing that the parentheses show up for now that I'm thinking about it.
So parentheses represent function definition, function calling, order of operations.
What is called the guard of a conditional. So guard expression is essentially the thing that's inside the parentheses.
All the stuff inside of the parentheses.
Yep. Inside the parentheses after an if.
Okay.
So if there's an if, paren, some expression, that expression is going to evaluate to either true or false. So greater than is a Boolean operator. It's going to say if this number is less than or greater than that number, it'll give you either true or false. So that determines whether or not the expression as the guard is going to set the conditional to actually do the things inside the curly braces or not.
Okay.
There's also another keyword, and I can put another set of curly braces.
So, okay, if else.
And I can have another expression over here to do something altogether different. You with me so far? So you understand the else is basically defined by its curly braces.
Yeah.
Okay.
Because so if the second parameter is 15 or less, then it'll run whatever it's below for else. Yeah. So the conditional statement. Yeah. Okay, I got it.
Okay. So the value of example 2 can either be equal to this expression or this one.
Okay. So else is like or, depending on if the second parameter is greater than 15 or not.
That's right.
Yeah, because you do an if statement, the output is a true or false, and if it's false, then you go to the else.
Yeah.
Yeah.
You with us so far?
Yeah.
Okay. So I'm going to show you one other thing. So here's a construct called a loop. So this is a ring. Okay. So the for, paren, double semicolon, end paren. It's just the way that that particular thing shows up. Usually you can put stuff specifically in here inside of these these things, but for the moment I'm just going to say, let's just leave it for now. I'm going to show you how else this works. So I'm going to set up another variable. Pick a number, 7. Okay, and then just for the interest's sake, right? Okay, so this ring construct, this for construct, is essentially going to do whatever it's in the curly braces over and over and over again until a break keyword is triggered. Okay, so the break keyword basically says leave the ring, so exit out of the curly braces and then do the next line after the curly braces that are associated with the ring. You with me so far?
Mm-hmm.
Okay. So what's this program going to do?
So for it'll do if how do I pronounce FLIIX? That's function of.
You just did.
Flicks. Okay. FLIX flick. I'll just call it flicks. So the variable's flicks equals 0. So the for function.
It's not a function.
I mean,
it's a ring.
It's a ring.
Right. So inside the ring, we're going to start the first line in the ring.
So the double colon represents ring.
The for open paren double colon close paren represents essentially an infinite ring. That's an unbounded ring in itself, and we created a bound by doing some things inside of it, and that's what we're now about to discuss. So a ring is essentially something that just does do this over and over and over again. Whatever's inside of its curly parentheses, curly braces.
Mm-hmm. Okay. So for that basically represents the ring. So to keep going over and over and over again. So
yep.
if the ring is greater than 7,
if the value of
the variable
FLIIX is greater than 7,
mm-hmm.
then the keyword break occurs and the ring exits, and this line here would be the return line would be the next one because it's the one immediately after the ring. The bottom of the ring is here. So basically the highlighted lines represent the thing that the ring's going to do over and over again because they're in the curly braces associated with the ring.
Unless the variable is greater than 7,
then it'll stop.
Okay. So it goes up and down around the ring until it's greater than 7, then it stops.
Okay, so what's happening here?
For this one?
Yeah, the highlighted line.
The log. So the function log1 is equal to whatever's inside of the ring.
Not equal to.
That's
the parameter.
The parameter of it.
Yep, so it's going to call, and so the log function, as you remember, just prints something to the log.
Mm-hmm.
Log is essentially the body of the document at this point. So it's going to take whatever FLIIX is, and it'll print it in the log.
So print that number below the other numbers.
Well, think carefully. What's happening? So program starts coming down, sees this function definition.
Yep.
Says, great, I got a function definition. It comes down here, it calls the function. It'll print the value of the function, calls the function again, print the value of the function, and then that's the end, right? So the first time it calls the function, it gets the parameters, in this case 453 and 35, does some math, sees that the second parameter is in fact greater than 35, so it does this other math equation. Then it comes down here, signs that value, comes down here, not yet greater than 7.
So 0 is, yeah.
Right? Then it does this. But it does this before it has come back down here, because it's still inside the function, it's still performing steps.
The function's nested under, yeah.
Okay, so what's it going to do?
So because flicks is equal to 0, which is it's less than 7, functional. Will it keep looping around?
How many times?
It'll keep looping around infinitely.
Nope. Oh, in this case it would. You're right. My mistake.
That's what I thought, because it's less than...
It stays less than 7. I need to do one other thing. Sorry about that.
So, because it's less than 7, so it'll just keep going.
It'll just do that. Now I'm...
greater than... Okay. Okay, that's what I thought.
You got me. I was just totally forgot to add that other line. Totally changes the behavior.
The numbers have changed on me. Okay.
Yep.
Okay, so this one is now if this is now if Flex is now represented as Flex plus 1. So it'll keep going. It'll like a click. It's like a stock click. It'll go 0, 1, 2, 3 until it's 7, and then it'll break. When it's greater than 7, it'll stop. So it'll return whatever that number is.
It'll return the example 2 number.
Example 2 number.
Yep.
Oh, the ring will keep looping until you hit.
Until we get 7. To that 7. Yeah. So it's going to print 0.
It'll keep adding 1, 1, 1. Yeah.
Yep. And then that'll return a value. Mm-hmm. It'll print that value. Then it'll call the function again. Mm-hmm. Right?
Yeah.
So what would you expect to see on the screen? Vaguely.
No value 1. So you'll get whatever that output is here defined as the first parameter.
In this case, yeah.
Yeah. So the variable mval2 is equal to the function of some odd calculation of parameter 1, which is 7.
No.
No. Oh, it's a big number.
It's some number because this here changed IIX, but it didn't return that. So it's going to throw those things out because when it returns, anything that was inside of this function call goes away. Mm-hmm. So it's as if we start from scratch the second time we call it.
It'll go back to the second line, which is function log1.
It'll go all the way back up to here. When this line is triggering, so the blue line is going to basically call all the way back up to this one.
So it'll put that number under function second parameter. So whatever that number is, it'll be if that number is greater than 15.
So the first parameter will be whatever the result of the first calculation is. Mm-hmm. Second parameter will be 15.
15.
Well, 15 not greater than 15.
So then it's going to go here. That. So then
it's going to do this line instead. Mm-hmm. Then it's going to come here.
Yeah, 15, and then 15 is greater than 7. The variable flux equals 0. So the ring, so you'll use the conditional statement if flux is greater than 0, it'll break it. So it won't run the ring because it's 15.
Well, where did flux is 0? So the 15 is up here.
What it'll do is the 0 will go through and it'll keep running the ring until it hits above 7. Mm-hmm. Oh, so that keeps repeating itself because you haven't changed the definition of what flux is. Mm-hmm. It'll keep running until it goes like 0, 1, 2, 3, 4, 5, 6, 7. And then it'll return example 2, which is the second parameter.
In this case, yeah.
Yeah.
And then I'll print that.
It'll print that number.
Okay, so what am I going to see on the screen overall?
See that. You'll see 15? No. It'll return FL example 2. You'll see 15, and then you'll see the second number, which is
Okay, I'm going to make a general observation, right? You'll only see on the screen things that are actually printed. Okay, so the thing to keep track of, what's actually getting printed when.
How do you know what things are getting printed?
Well, because the only things that are getting printed are things that are that are being handed off to this fn log, right? So this fn log occurs here, it occurs here, and it occurs there. So there's only 3 places where fn log occurs. The question is, what is the sequence?
What's the sequence of the order that they return?
What are they going to print?
They're going to return the one for ML value 1, ML value 2, and then when ML value 2 is inserted as value 1. So you have 3 different numbers?
No. Again, think in terms of recipes. I have the same recipe being performed twice.
Oh, you'll get you'll get a twice, not what's called duplicates, or not duplicates. You'll get double, so you'll get two of them. You're running
Two what?
2 different function logs. One with the parameter of ML value 1, one with the parameter of ML value 2.
Okay, I'm going to run this function, and you're going to explain to me why the screen shows what it shows.
Oh, so it showed all the steps of the ring.
Yeah.
Oh, okay.
You've got to account for that.
Oh, yeah, we got to take account for.
It's doing the things
clicker.
Inside the ring, right? The ring is inside the function. The function called twice.
And then the function of the 200 number goes.
Right. So it does the things inside the function. So this explains the sequence of operations. It does the thing inside the function. So you see the ring output its stuff. Then it comes out. That's after the thing was thing. It printed itself.
It was bigger than 15, and the second time it wasn't. So
it printed 15.
It ignored the
But it printed that sequence of inside the ring again.
Oh, I was ignoring the ring. Okay.
Well, yeah, but it's got a log in there. It's printed something.
Oh, okay.
Okay. So you got to actually read the code, right? So in other words, look at what is actually happening. What you're doing is you're following along with the sequence that the interpreter is going to interpret the instructions. And so you're running a model in your head that is essentially the same as what the model of the interpreter is running. And to the degree that what you think is happening and what the interpreter thinks is happening are the same, then the program's going to do what you expect. Mm-hmm. But to the degree that what you're modeling in your head is not the same, then the program's going to do things that you don't expect.
Yeah.
So in effect, it's really important that when you're reading the code's written in a way that your modeling of it is easy to do. But you still have to actually follow along, because if we misread it, of course, we're not going to see that the interpreter is going to see something that we missed.
Yeah.
So that's an example of that, right? Okay. So what happens if I take this whole thing, put it inside the ring, what's that going to do?
So the ring, build a ring function for double semicolon. If the ring, if flick is greater than 7, variable function, you're defining it as variable function. So you have 2 conditional statements inside of the ring.
Yep.
So if it's greater than 7, it breaks. If it's greater of the second parameter is greater than 15, then it runs the ring of all the math equations. And then the function of the log. So that's what it's going to print, which is example 2. And then flix is equal to flix plus 1. What would that represent? If flix equals flix, so that's like the counter step.
That's a counter, exactly.
Yeah.
So just to make it a little easier, let's change the name. Congratulations, you've identified the counter.
Okay.
Right, so you see I just replaced all the ones that are the counter so that they're in blue. Mm-hmm. That way there you can see that those variables aren't used anywhere else. So it's just a counter. It doesn't do anything else.
So you want to tell you what that whole thing outputs?
Yep. What are you going to see on the screen? Wait a minute, where's she going? guess the first skunk we've ever smelled out here.
Oh, there's skunk outside?
Maybe.
So you'll see the same ring 0, 1, 2, 3, 4, 5, 6, 7.
Why would I?
This is a ring, so if it's greater than 7, you have a break. This variable is example 2. It's greater than 15. Do all this math. Otherwise, you keep it. You define it as the second parameter. Log example 2. So this is what you're printing.
That's what I'm printing. So it's going to print a number.
So that number has to be greater than 15. So it would be. Does it have to be greater than 15 to be able to print it, right?
No, it's going to print whatever is in example 2.
Example 2 is example 2 squared plus times 1.5 times second parameter. Where's the second parameter? Our second parameter is 35.
Yep.
So it's going to be 35 plus, oh, it's the first parameter, so it's 453 times 453, so it's some big number, which is greater than 15, so it means it's going to run 30.
Well, the second parameter is greater than 15 in this case. The first parameter is used.
Yeah.
Second parameter is also being used. Second parameter happens to be 35.
So we know it's going to run that conditional statement.
Yep.
So example 2 is represented as example 2 squared times 1.5 times the second parameter, which is 35. So it's,
yeah, I just picked something that will give me changing numbers. The calculation is not important. It's the sequence that's important.
So after it does this, it goes down to here, so it prints whatever this outputs.
Yep.
And then we don't have to move to this one. This one doesn't print anything.
That's right. It doesn't.
Yeah, it's on an FN. And then it comes down to here, so it'll return.
Nope, because you have a brace here.
Oh.
It goes back up to the ring.
Goes back up to here, to the ring. But the ring will keep going until it breaks.
Yep.
So that number, so now that function counter, it's greater than 7, so it'll break.
Right.
Oh, it only needs to run once because the number's so big. The second time it goes, it'll break.
No, because the counter isn't entangled. These variables are separate. Right? So the value of fn example 2 doesn't have anything to do with the counter. The counter is a separate number.
Oh, so that's a separate number. So after it runs this once, using the second parameter 35, it'll run it again.
Yep.
The first parameter, it'll keep looping over it. It'll be the same number over and over again?
That's right, it will.
Oh, no.
So what do I expect to see? Same number.
The same number, just infinitely repeating.
Not infinitely repeating. I'll see it 7 times.
It'll go 7 times. Oh, okay, because every time it runs, it adds to the counter. Every time it prints, it's
printing the same thing over and over again because the parameters didn't change.
Mm-hmm.
Just the counter's changing. So it's going to print. It's going to do the same calculation redundantly 7 times over and over again because the recipe calls for it. But that's, not really of any use, but it's doing it.
Mm-hmm. Okay.
Then what?
Then after it prints it 7 times, then we'll go back to here.
Yep. Then?
Now that we've end this order of operations.
Yep.
Return FL example 2.
Yep.
And that is represented as, I guess, whatever we got from the log, right?
Whatever you got from the last calculation.
Yeah, whatever that number is. So it'll print that number. So it'll have the repeating number 7 times and whatever that is. And then we'll go down to this line.
Mm-hmm. Notice it didn't print.
Yeah, this one doesn't print.
Well, the print was down here. I took it away.
Oh. Yeah, because now these are just defining the parameters of these different variables.
Mm-hmm.
So then that's it. After it prints it 7 times.
Okay, the model in your head's not what's going to happen on the screen. Something different's going to happen on the screen. So what do I expect to see on the screen? You got the first half of it, right? What else is happening?
We'll see what FL example 2. you'll see this actual equation outputted, right?
No.
The second parameter. Will you just see these written as text? No.
No. So it's calling the same function twice. It's going to do that function twice. So the second time it's going to.
So it's going to have the seven. It'll duplicate exactly what happens. So you'll see that this happens 7 times, and then you'll also see the same thing.
But the parameters have changed.
But you'll, instead of using parameter 35, you'll be using parameter.
So some number from the previous call.
453.
So the 453 represents the parameter the first time. Then the function gets the output from there.
Mm-hmm.
So now fmval equals the output of this function. That's going to be put in as the first parameter of the second call. The second parameter is going to be 15 this time. So what's it going to print on the screen?
Oh, so then you'll run 15 through, but because 15 is greater than this, right?
The second parameter is not greater than 15, so the else clause is going to trigger.
So it'll print what the second parameter is, which is 15? That's 35.
It'll figure it out that the second parameter is going to be assigned to example.
Example 2?
Yeah.
So it'll put example 2 up here?
No, it won't. It won't go backwards. It's just going to execute the lines in sequence.
Oh, so it'll print this function of log1 of example 2.
Yep, which is going to be
15?
Yep.
Oh, so it'll print that number 7 times and then 15 at the bottom.
It'll only print the 15 7
once,
times.
Though. Oh, print it 7 times?
Right, because the counter is still going through. The counter is going through the ring. The ring is executing 7 times. So anything that's happening in the ring will happen 7 times.
Mm-hmm.
Because the ring is set up that way.
So it won't break. Okay. Yeah, it'll keep. So it'll run 15 7 times.
Yeah.
Oh, so 7 sets of each number, but there are different parameters. The first one's parameter 1, the second one's parameter 2.
Yeah. Defined by, well, the first one's defined by the calculation based upon whatever the first parameter made it be. The second one's defined by the second parameter because that's just how it happens to work out.
Mm-hmm.
Okay, I think that's it for tonight.
Can you save
I'm going to give you this whole thing.
Yeah, because I can annotate the notes on this now, like with the ring function.
So what I would suggest you do is go through this recording, okay? And I'll save these for you. I've got a thumb drive. What I'll do is I'll let you borrow a thumb drive.